Hello and welcome to today's MSSQLtips.com webcast, leveraging storage spaces direct for SQL Server high availability, sponsored by SIOS Technology. I'm Jeremy Kadlec, co-founder of MSSQL Tips and today's webcast host. Joining me today is Edwin Sarmiento, who is a Microsoft Certified Master and longtime MSSQL Tips author. Thank you, Edwin. Edwin will be sharing what we need to know about how to deploy SQL Server clusters using storage spaces direct. Before we get started, if you have any questions, you can submit them at any time during the webcast by entering your questions in the question area of the presentation controls. We'll try to have Edwin answer as many questions as possible during the tail end portion of our session. If you're not already a member of MSSQL Tips, we invite you to join. You can go to www.mssqltips.com and sign up for our newsletter, read any of our tips, download white papers, and watch on-demand videos. Please keep in mind today's webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's webcast. So Edwin, can you please help take it away from here and help educate the community?
All right, hopefully you guys can hear me well. Welcome. This is MSSQL Tips webinar, leveraging storage spaces direct for Microsoft SQL Server high availability. My name is Edwin Sarmiento. As Jeremy has already mentioned, I'm a Microsoft Certified Master for SQL Server, and I specialize in SQL Server high availability and disaster recovery. Now, if you have questions about this presentation, feel free to use the questions panel in the GoToWebinar app. Type in your questions. We'll field them in probably at a later time of this presentation. Also, usually I say good morning, good afternoon, good evening, but I don't know exactly where you are. But let's have a bit of fun while we're doing this. If you could type in the chat window what your favorite letter of the alphabet is, just for fun. It's going to come in later, and I'm going to use that as an example. If you could type in your favorite letter of the alphabet in the chat window. And you can connect with me, like I said, on my email, on social media, Twitter or LinkedIn. And let's get started with the presentation. But before we get started, we have a couple of poll questions. So first thing is, what's your favorite letter in the alphabet? And the second is, just one poll question. First poll question we have is this: do you currently have storage spaces direct in your environment? So we're going to put a poll question here. It doesn't really matter if you're using it specifically for SQL Server or any type of workload. I just want to know. This is to give us an idea of where you are at. Are you exploring storage spaces direct? Do you currently have one? And this will give us, like I said, an idea of where you are at right now. Are you evaluating? Are you planning? We'll give a few folks in here to answer the quick poll questions. Just wait for a couple of seconds for everyone to have an opportunity to answer the poll question. Do you currently have storage spaces direct in your environment?
All right, so Edwin, I'm going to go ahead and close the poll and share the results here real quick.
Sure. It's about 23% yes, 77% no. Like I said, it doesn't really matter if you're using it specifically for SQL Server or any type of workload. Second poll question, which is kind of like a follow-up question for that, is, are you planning on deploying storage spaces direct in the future? Maybe 3 months from now, 6 months from now, maybe before the end of the year. Are you planning? And again, it really doesn't matter whether it's for a SQL Server workload or for something else. I know this webinar is specifically for SQL Server high availability, but just to again see where you're at and how you want to move forward with storage spaces direct. Are you planning? Will you be doing this within the next 3 months, 6 months before the end of the year? Again, just waiting until everybody has had to respond to the poll question. And again, it doesn't really matter whether it's for SQL Server or something else.
All right, let's go ahead and I'm going to go ahead and close the poll, Edwin, and share the results. So
about half and half, roughly 50% or 45% yes and 55% no. and somebody said my favorite drive letter, not drive letter, but letter of the alphabet is H. All right, let's get started. This webinar is all about leveraging storage spaces direct for SQL Server high availability. But if you've been in my presentations before, you know I like using stories, and this takes me back to the time when I was learning how to drive. Probably if you have, if you're driving, you've gone back to the time when you're learning how to drive, this would probably bring back some memories. A couple of things that I was introduced when I started driving was, first off, things that I need to learn. How you hold the steering wheel, whether it's the 9 o'clock and 3 o'clock or the 10 o'clock and 2 o'clock, doesn't really matter. The point is you gotta be very confident. You have to be in control of the car. That's one thing that I learned when I was learning how to drive. The second one is the dashboard. How fast are you going? How slow are you going? Are you going beyond the maximum speed limit? Plus, do I have enough fuel to go through one round in the block? The dashboard, very, very important. And of course, where you're going. A driving instructor would say, always look at where you are going. Don't look at anything else. Of course, as you're building the skill and the confidence to drive, it also gives you, the opportunity to look around. But initially, when you're learning how to drive, these are things that your driving instructor or whoever's teaching you how to drive would hint at. Make sure that you're holding the steering wheel properly. Make sure that you're looking at the dashboard regularly, and make sure that you're looking at where you want to go. At the end of it, of course, you take your driving test, and eventually you would get your own driver's license. Now you're ready to drive. But here's something that I've realized ever since, and I've been driving for quite a while, about more than 20 years. And here's something that I just recently realized, that more often than not, when we're learning how to drive, or even when we're driving, a lot of these things have been fully taken into consideration. Your car, looking at the dashboard, looking at where you're going, making sure that you're placing your hands properly on the steering wheel, making sure that you have your driver's license. But what we sometimes take for granted is the fact that there's one very important thing to consider, and that is the driver himself. Wait a second. Isn't that the whole point of why you're driving? Of course, but more often than not, we take for granted the idea that in order for you to go from one place to another, apart from the car, is the driver. So ever since automobiles have been invented, car manufacturers think about the car. Driving instructors think about how you want to drive. When you're getting your driver's license, how you would pass the test to get your driver's license. But we almost always take for granted the driver, which takes me back to our day, 21st century, when we're looking at the concept of driverless cars, self-driving vehicles. For ages, decades after decades of, working and driving a vehicle, now comes self-driving vehicles, which changes the way we perceive and how we look at driving. In fact, I'm excited to go back to Philadelphia just so I could try out self-driving Uber. How cool is that? Cars without drivers. And it's something that redefines how we look at driving in itself. Why am I even highlighting this? When you think about SQL Server high availability, specifically failover clustered instances, when you think about failover clustered instance and how high availability is factored into failover clustered instance, ever since the beginning, when we're looking at a failover clustered instance running on top of a Windows Server failover cluster, you can't really get away with a SQL Server failover clustered instance without this magic box, the black box, called the shared storage. Very commonly known as storage area network. Any type of shared storage subsystem. This is the secret to what makes SQL Server failover clustered instance happen. And this dates back to the good old days of SQL Server 7, Windows NT4, SQL Server 7. The magic behind Windows Server failover clustering plus failover clustered instance is actually the shared storage subsystem, storage area network. This is how SQL Server makes things highly available. Of course, the idea behind that is your database files are stored inside the shared storage subsystem. And the evolution of Windows Server failover cluster from the NT4 days to now the Windows Server 2016 days, it's still the same concept for failover clustered instance. Your SQL Server binaries are installed on all of the nodes in the cluster, and all of your database files are in the shared storage. Again, this was the foundation of how failover clustered instance worked. In today's age, you probably heard of software-defined data centers where everything's virtualized. Software-defined networking, software-defined data centers comes the concept of software-defined storage. Because in reality, when you're looking at that shared storage subsystem, it's expensive, it's complicated, it's confusing to even set it up. I mean, think about this. Mid-2000 was the time when new job titles in the IT industry, such as storage engineers, came up. Like, I'm a SAN engineer, I'm a storage engineer. This was those times when those specific job titles came up. And now with the modern data center, where you have storage, software-defined storage, and of course the fact that storage area networks are expensive. Let's face the fact that they're expensive, they're very difficult to maintain, comes the idea behind virtualizing storage. Now, this is nothing new. The concept behind virtualized storage is nothing new. When you think about this, even in the good old days of Windows NT, where you present one physical disk to a server, and then you carve off multiple volumes within the same physical disk. That's a very simple example of storage virtualization. But now with modern data centers, the idea of provisioning virtualized storage using software-defined storage is even more made advanced, if you want to think about that. The idea being is because of the cost associated with storage area networks, companies like Microsoft and other software vendors came up with the idea, why don't we eliminate the need for storage area network or shared storage and use locally attached storage instead? Now, the idea, of course, that SQL Server failover clustered instance still required shared storage because, quite frankly, it's still the same old methodology. SQL Server failover clustered instance running on nodes in the cluster, and they're all accessing the same data files, data and log files stored under some form of shared storage. This is where Storage Spaces Direct come in, and it's introduced in Windows Server 2016. And what is Storage Spaces Direct? When you think about Storage Spaces Direct, and I took this definition from the Microsoft documentation, but basically you're using commodity servers with, take note, locally attached drives. We're not talking about storage area networks. We're not talking about shared storage. We're simply leveraging locally attached drives to create highly available, highly scalable, software-defined storage. Now, when you think of this, you could think of it as I've got a commodity server just using locally attached storage, and I'm going to build a cluster using those cluster nodes, and I'm going to create some form of a virtualized storage and making it look like as if it was shared storage if I'm presenting it to the SQL Server failover clustered instance. The idea behind this is the storage is replicated across all nodes in the failover cluster. You might want to think of this as, hey, just like always on availability group replicating, but it is happening on the storage layer, not the application layer. It's leveraging existing technologies. We're not looking at something new here. We're looking at things that have been in existence ever since, I think, Windows Server 2008. For instance, cluster shared volumes. This technology has been in existence in Windows Server 2008 R2. It was designed specifically for Hyper-V workloads. It was only in SQL Server 2014 that Microsoft supported running a failover clustered instance on top of cluster shared volumes. But the reality is, it's been there since Windows Server 2008 R2. And we're looking at server message block, or SMB, the way you access file shares. This is Microsoft's implementation of accessing file shares. It's been there. We've been using SMB since, again, good old days of Windows NT4, but a much improved version. And of course, Windows Server failover clustering. Since SQL Server failover clustered instances already leverage failover clustering, why not take advantage of that? And storage spaces, which was introduced in Windows Server 2012 release. Can't remember if it's R1 or R2. But the idea here is, if you're learning or if you're moving into storage spaces direct, you already have what it takes to implement it. If you know how to work with cluster shared volumes, if you already know how to work with Windows Server failover clustering, and even storage spaces, you already have the right skills to build a storage spaces direct cluster. It makes local storage appear like shared storage. Again, the idea behind failover clustered instances still leveraging the concept of shared storage, right? Because your database files, your MDF and LDF files, still sit on quote unquote emulated shared storage. It is local storage, but as far as SQL Server is concerned, it's as if it is a shared storage. So when you look at that, and I took a picture of my, kind of like my home lab. I only have like one machine for my home lab, but I took a picture of my HVDL 380 machine. So let's say I got 3 of these machines, and let's say each machine would have 1, 2, 3, 4, 5, 16 1 terabyte drives. What you could do with storage spaces direct is you can create a Windows Server failover cluster using these 3 nodes. Could be 2, but I'm just using 3 as an example. And when you enable storage spaces direct, what it does is it will create one pool of, I hope I did my math right, 48 terabytes of disk space in one storage pool. Now think about this. They're local drives. They're in their own storage enclosures. No SAN, no shared storage, nothing. They're all local disks. In fact, these are commodity servers anyway. And you could leverage 48 terabytes of disk space, again, just like having one physical disk with multiple volumes and partitions. You can then create logical volumes off of this storage pool and present it to your cluster, not cluster, but cluster workload, like SQL Server failover clustered instance as an example, and use that to store your database files, your log files, or even your backups. Now, let's take a look at the underlying architecture that makes this possible. Like I said, these 3 machines could be, your Lenovo servers, in my case, HVDL 380. Each one will have locally attached drives. You build a Windows Server failover cluster using these machines, because these machines have their own locally attached storage. Storage spaces direct will then leverage these drives and create one huge storage pool that you could use for any workload in your cluster. What makes this possible, again, the technologies that I've already mentioned, is the fact that the failover cluster and storage spaces direct will create what is kind of new in Windows Server 2016. I say kind of because it's already 2018. Software storage bus. When you think about this, when you look at how storage spaces direct work in the traditional shared storage mechanism, where every node in the failover cluster will have to be physically attached to the shared storage. The reason being is because every single node in the cluster needs to have access to the disks, because it needs to be able to take ownership of the drives, for failover and storage ownership. Think of the storage, or rather the software storage bus, as the software equivalent of your fiber channel or SAS connection to your storage. But because of the fact that they're all locally attached drives, it is storage spaces direct using this software layer that makes all of the local disks accessible to every node in the failover cluster. And then we have Ethernet plus RDMA, or remote direct memory access. Think of this as fast networking. This is leverage, SMB, or server message block, uses fast networking. You can't just plug in, run-off-the-mill network adapters for this. You need fast networking to make this happen, because you're looking at replicating data across nodes in your failover cluster. And again, we'll talk about that later as we are looking at the different components here. And then you have storage spaces that is responsible for allowing your locally attached drives to appear as one storage pool, and then replicating the data, virtually making all of those locally attached disks function as if it's a single disk from the point of view of the application. And then you have cluster shared volumes, again, making the logical drives appear as if they're connected to all of the nodes in the failover cluster. Now, earlier I did ask what your favorite letter of the alphabet is. Somebody said H, somebody said F. The reason being is, in the traditional way of building SQL Server failover clusters, while Microsoft says it supports running up to about 50 SQL Server instances in a failover cluster, the reality is you're limited by the number of drive letters in the alphabet, number of letters in the alphabet, which is kind of interesting, because you can no longer use the drive A, B, and C, right? So you can use D up to Z or Z, depending on who you're talking to. And that is the limit to the number of SQL Server failover clustered instances that you can run on top of a failover cluster. But with cluster shared volumes, these volumes appear as if they were just simply folders instead of drive letters, which means you're eliminating the limitation for the maximum number of SQL Server instances that you can run if you're using drive letters, which is why, like I said earlier, the reason why I asked what your favorite letter of the alphabet is, because you're now removing that limitation. Now let's look at some of the hardware requirements here. I know I did use 3 machines or 3 servers in my example to build a failover cluster, but nobody's stopping you from using a minimum of 2 servers. The goal there is high availability. From the memory perspective, this is SQL Server, so you want to have as much memory as you can provision to a node of a failover clustered instance. But if you're leveraging storage spaces direct, you need at least 4 gigabytes of memory per terabyte of cache drive capacity on each server. So for instance, if your cluster node has, let's say, 128 gigs of memory, and you're leveraging storage spaces direct for that cluster, and you want to run SQL Server failover clustered instance, you're limited to, well, I don't want to say limited, but your working memory set for SQL Server is around 120 gigs of memory. So you have to set your maximum server memory configuration for SQL Server so that it doesn't use those, all of the memory available on the server. And then for your boot drive, because these are locally attached drives, you still need to protect your system drive or your boot drive. So recommend is about 200 gigabytes, although in my case, I just usually carve out 100 gigabytes, but it depends on the size of the drive available. When you talk about networking, because this leverages SMB3 and fast networking, it is highly recommended that you have fast network adapters, minimum of 1 network interface card per server, not highly recommended if your goal is high availability and resiliency. In fact, I standardize on having at least 2 network adapters per cluster node. more the better, of course, depending on how you want to configure it, physical versus virtual. Microsoft recommends remote direct memory access capable NICs, or RDMA NICs, and the reason for that is you want to provide fast network connectivity between the cluster nodes, because think of storage spaces direct as kind of like a RAID implementation, a software RAID implementation scaled out across multiple servers, and the way that the cluster replicates and the way storage spaces direct replicates the data across all of the nodes in the cluster is through TCP/IP, SMB. That's why you need fast network adapters. In fact, the server that I'm using for my home lab, it's an old DL380, and it comes with the standard network adapter. So if you're building a storage spaces direct cluster within the next couple of months, make sure that you tell your hardware vendor to provision RDMA capable NICs. Because in my case, I had to buy them off the market and plug them into my server. As far as drives, the beauty of this is you can build what is known as a tiered storage subsystem. So you no longer have to rely on third-party storage vendors to provide tiered storage capability to your storage subsystem. So you can have a combination of NVMe drives, SSD drives, rotating disks. So what you could do is you could store your backups, because they don't need fast storage subsystem. You can store your backups on rotating drives, your data files and your log files on SSDs, if that's how you want to configure that. The same number and types of drives in every server. So you don't want one node in the cluster to have 4 drives. The rest will be 5 and 7 or 8. They have to be the same. Okay. RAID controller cards or stand storage are not supported, because this is an implementation of some form of a RAID, but on a software level. In fact, in my case, I had to remove the RAID configuration on the server when I got it. Now, there are a couple of use cases that you can work with. Leveraging storage spaces direct. Like I said, majority of the feature set that were introduced in Hyper-V, or rather in Windows Server failover clustering, since Windows Server 2008 came out, were all for Hyper-V workloads, which is kind of different, because in the old days, and I'm talking about NT4, 2000, 2003, the top 2 workloads that run on top of Windows Server failover clusters are SQL Server and Microsoft Exchange. But things have changed starting with Windows Server 2008, when Microsoft has released Hyper-V, and so it kind of tilted the top workloads. Now it's all Hyper-V, and which is why a lot of these features that are being introduced in failover clustering target the Hyper-V workloads. And that's why you have you could use this primarily for storage systems for Hyper-V, or even run the Hyper-V cluster in the storage within the same system. Like I said, in the previous versions of Windows, Microsoft SQL Server and Exchange were the top 2 workloads that run on top of the cluster. And so there are still customers out there. I've worked with a lot of customers who are still leveraging failover clustered instances, and that's why Microsoft still continues to support SQL Server to run on top of a Windows Server failover cluster. You could use this as well for highly available file shares. In fact, one of my customers is building a storage spaces direct cluster primarily for their file share witness. So you're creating a Windows Server failover cluster, and you want your witness to also be highly available. Of course, it doesn't make sense to put your file share witness on a workstation, although you could do this. Looking at the Q&A panel here, a couple of questions that came in. First off, could you use SMB in a cluster to present to a SQL Server to make storage highly available? I am going to answer that question in the next slide. That's actually a good segue into it. The next question is, how do you set up LUNs in storage spaces direct? How can you have separation of volumes, or does storage spaces direct only sees the pool as a unique LUN? Yes, you can. In fact, I'm going to show you. I'm going to reference that later, about 2 or 3 slides from here. Can you use a hypervisor on top of the nodes that are set up with storage spaces direct? Yes, you can. The hypervisor, of course, is highly recommended to be Hyper-V. Are the hardware requirements that you noted earlier the same for on-prem and cloud implementations? Now, here's the thing, though. When you're talking about on-premises, yes, because you have full control of the hardware that you want to use for your implementation, right? You could tell your hardware vendors, these are what I need. But in a cloud implementation, of course, there's two types of clouds. Private cloud, which means you're still the one responsible and you have full control of what type of hardware you buy. But for public cloud implementations, of course, you don't have any control over that. However, if you're deploying storage spaces direct for Azure, for AWS, or Google Cloud, you could provision storage that you attach to those machines, right? When you create your VM, you define storage, local storage for those, and you can use those storage to build your storage spaces direct cluster. But again, they have to be the exact same configuration per VM. And again, totally different when you're looking at private cloud versus public cloud, because with private cloud, you could dictate whatever type of hardware that you could use for your own implementation. So let's look at storage for SQL Server failover clustered instances. And this is what I was referring to earlier. There are two types of implementation. This is not just for SQL Server, right? This is very common with other types of workload. I'm just using SQL Server as an example because, again, this is MS SQL Tips, and you guys are all SQL Server professionals anyway. The first concept is called hyperconverged. This is when the storage, compute, and networking are all in a single system. And I'll give you an example here where you get, like I said, I'm using two nodes for this example. You provision a Windows Server failover cluster with nodes that contain locally attached disks, no shared storage, nothing. Create a Windows Server failover cluster, create a enable storage spaces direct, create the volume, and the nodes that have storage spaces direct is the exact same node that runs your SQL Server failover clustered instance. In fact, like I said, I'm going to segue into this. I've written I think it's a three-part series article on MS SQL Tips on how to install SQL Server 2016 on a Windows Server 2016 failover cluster without shared storage. And this is an example of a hyperconverge. If you look at it, in fact, I strongly recommend that you visit msqltips.com and look at that article that I've written there, where I walk you through the entire process of building a failover cluster, enabling storage spaces direct, creating the volume, and presenting that volume to SQL Server when you install a failover clustered instance. This is an example of a hyperconverged system. Now, hyperconverged system, again, using the example where that I use for the MS SQL Tips article, is everything is in the same cluster. Your storage is in there, and the SQL Server failover clustered instance is in there, right? The compute, which is the node that is running your SQL Server failover clustered instance, and the storage, they're in the same machine. In contrast, there is another way to implement some form of storage for SQL Server, and this is called the converged system, where your storage and compute are in two separate systems. So you're looking at the one on the left where you have a failover cluster running storage spaces direct, and its role is purely just for storage. Think of this as a highly available, storage subsystem. And the one on the right is a dedicated failover cluster, dedicated Windows Server failover cluster that's specifically designed to run SQL Server as a failover clustered instance. Now, keep in mind, when SQL Server 2012 was released, you can now you can now install a failover clustered instance and store your database files on a file share. In previous versions, it has to be a drive letter. in SQL Server 2012, and later you can present a file share. Just make sure it's a highly available file share. You can present a highly available file share as you go about installing a SQL Server failover clustered instance. This is an example of a converged system where you're separating your compute, which in this case, the two nodes that run your SQL Server failover clustered instance, and your storage, where your database files and your log files are stored. Okay. Now, I know I talked about a lot of these features and concepts and capabilities, and I hope that answers the question: how do you set up? I'm going back to the questions here. How do you set up LUNs in storage? Can you have separation of volumes? And that's an example, right? Where you have SQL Server running on the same node as the storage, or you could have SQL Server running on a different cluster as the storage subsystem. Okay. They have an example of installing SQL Server 2016 on a Windows Server 2016 failover cluster with HA. Yes, those are in the MS SQL Tips article as well. I've written a couple of articles since last year on how you could do this either with storage spaces direct or the traditional storage area network or shared storage, both providing high availability for SQL Server. Now, I did mention that it's fun. It's great that Storage Spaces Direct has provided us with the capability of enabling high availability for SQL Server without the traditional way of doing things, which means I no longer have to rely on expensive storage area networks. And again, it changes the way we do things when we're dealing with a failover clustered instance. Tying it back to the story that I mentioned earlier, it's just like, hey, we're living in the days of driverless cars. Here, we're living in the days of failover clustered instances without the expensive SAN, without the concept, well, not really the concept, but without shared storage, because everything that we've been looking at right now is everything that we're looking at right now are all locally attached storage. But, and this is where I kind of like segue into, but it's not without drawbacks. Okay? It's good, it's great that we no longer have to deal with expensive SAN, but a couple of drawbacks here. First off, it requires Windows Server 2016 Data Center Edition. Now, I know somebody might say, well, when you compare the licensing cost of SQL Server Enterprise versus Windows Server Enterprise, it's nothing, right? SQL Server Enterprise is way, way, way expensive. But here's the thing, though. You're looking at reducing your total cost of ownership. It doesn't make sense for me to have, let's say, for example, standard edition SQL Server if I want to deploy a failover clustered instance and leveraging or using Data Center Edition. If, for standardization and again, lowering total cost of ownership, if I have SQL Server Standard Edition for my failover clustered instance, then I might as well just use Windows Server Standard Edition. But in this case, Storage Spaces Direct is only available in a Data Center Edition. In fact, when this came out prior to RTM, we did ask Microsoft if they can provide a kind of like a lower edition version for Storage Spaces Direct, but up to now, it's still only available in Data Center Edition. Another one, it only exists in Windows Server 2016 and higher, which means if you have a workload that requires or that doesn't support 2016 just yet, you can't leverage this. And of course, we're living in reality of some software vendors would say, oh, I don't support Windows Server 2016 just yet, which ties back into SQL Server because we're looking at SQL Server here. I know one customer that I work with, their software vendor said we don't support SQL Server 2016 just yet. I mean, come on, it's 2018. We already have SQL Server 2017, and they still don't support SQL Server 2016, which means if you have application or legacy applications you want to provision high availability for, you're stuck with that version. You have to look at other alternatives. In order for you to leverage Storage Spaces Direct, with SQL Server, it has to be SQL Server 2016 and later. In fact, we had this conversation last year when I, with Microsoft, when I wrote the series of articles on Storage Spaces Direct for MS SQL Tips, is the official support documentation for the versions, because there is no explicit statement from Microsoft that says we're supporting 2012 and 2014. So we did ask, and after that conversation, they said we only support SQL Server 2016 and later. Again, one of those bigger challenges, because again, in the real world, we're still dealing with older versions of SQL Server. Although totally recommended that you move off of unsupported versions, but no, we're living in the real world for now. There's also this lack of robust DR solution. Now, when you think about this, we're not just looking at HA. Storage Spaces Direct is amazing for HA, local high availability. But on top of local high availability, applications or even businesses require a disaster recovery solution. Now, interestingly, of course, when you think about it, hey, why don't I just add a new node in my Storage Spaces Direct cluster and put that cluster node on a different data center? Wouldn't that be a good DR strategy? The challenge there is because of the fact that you're dealing with high-speed networking connection between nodes in your failover cluster, there is no guarantee that that will be the same bandwidth that your cluster would use when you're crossing data centers. In fact, Microsoft in their support documentation would recommend that you would use, on top of Storage Spaces Direct, storage replica, which means locally for nodes within the same data center, you use Storage Spaces Direct. But in order to replicate that storage over to a different data center, you would then have to use storage replica, which is another layer of complexity when you try to implement a combination of local high availability using Storage Spaces Direct with disaster recovery, which is, again, another layer of complexity. And I'm seeing more questions come in the chat window. See here, you have samples. Why would you use a failover clustered instance instead of AG, as we can now have two replicas availability groups on standard edition? Very good question, but keep in mind though that in basic availability groups that are that's available in standard edition is the fact that you are creating one availability group per database, which means you can only add one database per availability group. Now think about this. Every availability group requires a listener name. Every availability group would require a resource group in a failover cluster. So you've got 25 databases in standard edition, and you're moving into basic availability groups. You basically have, and I say basically basic, 25 listener names, 25 resource groups, which becomes a nightmare when you're trying to manage basic availability groups in that situation. In a failover clustered instance, you only need one resource group, one network name, and put all of your databases in that rather failover clustered instance. Another question here: if we use file share for SQL, then what about IOPS? Will it impact the performance of database? For file share, your bottleneck would become, assuming of course that you're using a fast storage subsystem, your bottleneck will become your networking, which is one of the reasons why it's highly recommended that you use RDMA capable network adapters. Would you recommend, another question here says, would you recommend running SQL servers on virtual machines inside Hyper-V with Storage Spaces Direct? For testing, yes, but keep in mind that you are leveraging the network layer for replicating the storage. So that would impact the availability of the traffic when you're dealing with guest clusters. And I've seen a lot of cases in the past where a task like taking storage snapshot of a VM would cause the guest clusters to go offline because it's saturating the entire network. Now, going back to this, like I said, while this is exciting, this is fun, we have a couple of limitations still with storage spaces direct, especially when you're looking at providing high availability to plus disaster recovery to your SQL Server workloads. And this is where I'm going to hand it over to Mike to talk about how the limitations for working with storage spaces direct can be addressed using a SIOS. Take it away, Mike.
Hey Mike, it looks like you're still on mute. Could you also share your screen? There you go. Hey Mike, it looks like you're still on mute. Hey Mike, this is Jeremy. It looks like you're still on mute and you have your screen shared.
There we are. Go ahead, Mike.
Hey Mike, this is Jeremy. It looks like you're still muted. Your microphone is muted, Mike.
And while we're waiting for Mike, maybe there's a couple of questions that are you want to ask in the presentation. Feel free to use the questions and answer. There we go.
Sorry about that. Anyway, yeah, I don't know why the system didn't let me really unmute myself. Anyway, so let me introduce myself briefly. My name is Michael Trout. I've been in the industry since 1999, working with tier 1 applications, major storage company, et cetera, hands-on experience with many tier 1 applications, mainly from backup and recovery space, which entails many elements of application health and application behavior and DR situations and bringing me now into the high availability space with SIOS. It's a natural progression in my mind. So let's just briefly speak about the traditional cluster, right? Traditional cluster, I'd have an app with shared storage. However, if that shared storage went away, there's no failover option there. That shared storage goes away and everything goes down. I might have protected my compute node, but traditionally in the shared storage environment and that topology, that single point of failure simply does not work. So the SANless clustering SIOS DataKeeper enables this equal size volume replication, much like S2D, but we can set synchronous or asynchronous. It's a low latency block level replication, which initially presents many benefits. So it's basically a network block device relationship between the source and the target. And this intelligence that's built in between the nodes also relies on a bitmap file. So if you're doing maintenance or something like that, we don't have to have full resyncs occur, etc. But that replication, if that volume goes away, we will fail over working with Windows Failover Cluster Manager with our tight API integration into that product. All of these applications, what have you, not limited to SQL Server, will fail over, and we will control the disk behavior and make that read writable on target nodes. I could also add multiple replication targets. So many people say, okay, my HA is fine on-prem or in this cloud between AZs, multiple AZs. I think I'm protected, but what happens when that region goes away? Or maybe there's a fire flood or other detrimental result on that site. I can add a third node either out of region in the cloud or maybe at my DR site. And it's just set it and forget it simple. The replication and management DataKeeper Cluster Edition is the simplest administrative task you will ever do. You just present the volume to DataKeeper from drive letter, make equal volumes in the target, and configure the replication. We'll see that in the demo in moments. We'll just fly through a failover situation. So now that second node owns that SQL instance and all of its applications, etc., in the FCM. But that first node is gone. So what happens when I lose this node also? Have no fear, because it understands the topology. And when other nodes come back online, we will resume the replication with that bitmap file to avoid full resyncs in a way that has only incremental updates based on the knowledge that this copy is owed X amount of blocks based on that bitmap file. That bitmap file is very lightweight. It's basically ones and zeros based on the disk geometry inclusive of the block layout. Okay. So how about multi-site and hybrid storage situations? I might have a local site. I might have then a DR site, or in the cloud, which we'll get to in a moment. Maybe that's a cloud target. I can go hybrid. I can go on-prem. I can go between clouds. I can go wherever I need. This no configuration limitation is probably the largest takeaway of DataKeeper Cluster Edition. It's just that simple. We rely on just supported OSs all the way back 2K R2 and beyond. So that's a huge differentiator here. We can support where you're at, regardless of where you want to be. We do support 2016 today, but all of these layouts and topologies are supported. Physical servers, multi-site environments, hybrid cloud. We can go into virtual environments, whether it's VMware, Hyper-V, etc. High performance storage inclusive. We have awareness and integration in the event that that storage array may present a protected volume itself. And of course, in the cloud collectively. And we see a lot of migration into the cloud layers across all of the platforms, Google Cloud, Amazon, Azure, all of those things, because we're host-based, we can go anywhere, okay? So the key features here, this host-based data replication, leveraging the existing LAN, and today's LANs are typically 10 gig and beyond. I know it was mentioned by Edwin about, having direct RDMA access type of NICs. Yes, if you have physical nodes, that would be optimal because the replication does occur over a LAN link or a WAN link. We can go multi-target. You just add the target, and if you want it asynchronous, you have it. It's really wizard-driven configuration that is just so simple. We'll get that in the demo coming up. But it's at the block level again, as I mentioned. This volume long replication, it's a change-only replication. So even if you're doing maintenance on a SQL node, you need to reboot because of an OS patch. You need to reboot or restart services or what have you that takes away the synchronized copy. When that comes back online, we will use this bitmap file to avoid those full resyncs and only send the owed data. It's an enormous benefit out there if synchronization based on normal wear and tear, if you will, in a data center environment, whether it's cloud, hybrid, or on-prem. These things are natural occurrences, right? So as a system has to get rebooted, etc., I need the ease of administration to evacuate all that responsibility from that host, and the API integration into Windows Failover Cluster Manager is very tight, which means that if I'm using DataKeeper to evacuate a disk for some maintenance or maybe volume resizing, what have you, we communicate with Windows Failover Cluster Manager, and because that dependency exists, the FCM will perform that failover for us, even if you're using the DataKeeper GUI to move a volume back or forth, etc. So let's hop into the live demo, and this we'll start at the high level first, and then we'll come back up for air, and I'll just show you if we could just get a quick ping on the screen here. So we have a cluster, right? Traditional SQL cluster, 2 nodes. All the roles related to MS SQL Server are here. We have the server name, the VIP, SQL Server is running, the server agent. The DataKeeper volume, this represents the integration. I know my source system is SIOS 1. That is the owner right now. It's replicating to SIOS 2. If I needed to, let's say, evacuate that host, I need to move all the responsible resources. Click, click. Notice I'm not using any SIOS here. I just told it, go to SIOS 2 now because I need to do some maintenance in SIOS 1. And with the seconds that are ticking by as I'm speaking, you'll see the DataKeeper volume will switch to SIOS 2. It will bring up all of the relative resources, and now everything's running on the second node. So these nodes that are in here, I'm going to now go and stop the cluster service. This is an example of, oh my goodness, what happened? Somebody shut that server down. Well, our tight API integration will enable confidence at a layer of, don't worry, Windows failover clustering is going to do its job. We told it what was going on. There's no, necessarily a worry to be had. So I'll resume the cluster service on that second node, reflecting that detrimental failure. And now let's take a look at DataKeeper's GUI. So I see my existing overviews. I'm mirroring a pair of mirrors. I'm going to create a new job. So let's create a file share that is also cluster protected. I'll select my volume. I'll choose which network I want replication to occur on, which is a critical choice to be had. And then I'm going to say synchronous because this is within region/on-prem. It'll create the mirror initially with the DataKeeper. Once the DataKeeper layer is there, I'm going to enable it to present the cluster resource to the OS, the online pens. Now I have available storage as drive R. I'll configure a new role here. As I mentioned before, let's make a clustered file server. General use, I'll name it whatever we want to name it. This is an FS or a file server cluster protected situation. I'm going to give it the IP address for accessing its resources, and I'm going to select the storage. Notice it's a DataKeeper volume, right? That synchronization is already happening behind the scenes. So now it'll add all of those resources to the FCM, and you'll notice now it's appending all of the dependencies, etc., to this file server resource. Now it's online. So we just walked through all of, fast forward to, hey, this is SQL running, into how do I add a new resource to Windows Failover Cluster Manager, and how simple really is it? I've heard your product is simple before. I heard it's set it and forget it. The tight API integration, as you saw on this demo, it is the truest thing ever stated. These are not marketing words, right? And by the way, our support goes back to 2K8R2. We're not restricted to SQL only. This can truly be a data replication to enable AHA for anything that can integrate into Failover Cluster Manager. One of our famous use cases is a big gaming company that rents games, etc. They were not ready to upgrade their application that used SQL. Well, here comes the problem. That application does not support always-on availability groups because it's an aged app. Well, in comes SIOS. We configured our data replication layer with the DataKeeper Cluster Edition, and they were enabled to migrate all of their resources into the cloud. And that speaks volumes in itself, so to speak. No pun intended, haha. But so that summarizes the demonstration. We can pop back to the slides, but the big advantages here, anything from 2012 R2 to 2016, we do not require data center addition. On a 2-node cluster, we don't require SQL Enterprise. We can go with 2 nodes of SQL and have that HA cluster up without the license overhead. And if anybody knows that always-on availability incorporates enormous license costs, especially if you're beyond the 2 nodes that force enterprise licensing, those Excel sheet entries are very, very large. We also have support on the Linux platform. Now, the Linux SQL Server on Linux is actually Microsoft SQL Server's release on Linux in the latest release. We protect that also. And the Linux flavors do not stop there. SAP, Oracle, MaxDB, Sybase, basically any application that has a stop, start, restart, and a health check, we protect on Linux. And we standardize sort of the cluster manager that Windows has. We have one failover cluster manager for Linux platforms across, SUSE, OREL, RHEL, CentOS, all of the major vendors on Linux. So just one thing to quickly point out. We support 2K8R2 through 2017. Standard or enterprise, as I mentioned before. These DR solutions, multi-site clusters, I can add a copy, I can set it asynchronous to not bother my performance of the on-prem or the in-region copies of nodes that I have. We can have integration with always on if you so choose, just for the simple purpose that our replication is just that simple, right? And we also support the ASR in Azure. So any storage. So this is sort of on-prem story, but I don't care if it's a SAN, iSCSI, VMDK presented, VHD, local disk, RAID, etc. We will get that object and we will replicate at the block level between these nodes, whether it's 2 nodes, 3 nodes, out towards, dare I say, it's something else, it's 36 or something. But the only requirement is it must be an NTFS formatted volume, and I don't need a cluster shared volume. I don't need to create storage pools. There's no replication locally required if I choose to change my topology. Right? This is truly a set it and forget it solution. So I don't need a 10 gigabit LAN because of our efficiency at that bitmap. It all depends on really the IO driving the application. Of course, we need to send that as updates to the target. We don't require RDMA type of NICs for that efficiency in itself. With the benefit of the bitmap file avoiding full resyncs, we also only need to send new data across that wire. And that the synchronous or asynchronous options enable us to go anywhere. I can go across from slow LANs, different buildings, over to a wide area network topology, which, as I mentioned, on-prem, cloud, hybrid, etc. We can go anywhere. We're host-based. I don't care where your host is. SIOS will just do its job. And the only question is latency, bandwidth availability over the LAN. We have some late-breaking customers now who are actually replicating cross-region with dedicated pipes in the cloud because finally they bought their own specific networks to interconnect regions, and that latency is keeping up based on their IOP workload, of course, right? We're not going to go to the maximum highest performance in that topology, but the point being is the efficiency is there that really enables options for customers. Any hardware, physical, virtual, in the cloud, or any private public cloud. If you have a machine that is actually Microsoft X 2012 R2 through, we will be able to be installed and used based on other variables such as latency and bandwidth availability between the internetworking, whatever that is, whether it's LAN or WAN. That was my quick time, and I know Edwin had a lot to say, but I think the S2D topic is something to truly keep an eye out for and keep up with, that late breaking technology. But in the same breath, it's new and it's young, and the restrictions, etc., and the features of robustness, I'm sure they will come one day. But the SIOS solution has been doing this for 2 decades now, and it's just set it and forget it simplicity.
Mike, thanks so much. So let's go ahead and push out a quick poll. So to everybody in the community, if you're interested in learning more about high availability in the cloud, if you could please respond to our poll. So the first option is yes. Second option is yes, but not right now. And third option is no. So definitely appreciate all your information today, both to Edwin and to Mike. Definitely very interesting to see what's available natively with the Microsoft products, as well as what's available with SIOS and all that SIOS enables customers to do on-prem and in the cloud. So definitely thank you guys for providing all that great information. We do have a lot of questions. I know Edwin did address some of them. I've passed a few along over to Mike. We're going to hopefully wrap up here in the next little bit here. So if we're not going to be able to get to all the questions today, and I do apologize for that. If people do have the questions you have posted, we will pass along to Edwin and Mike and have them respond after the call today. If you do have additional questions, please feel free to post them right now so those can be included as well. Definitely be very, very much appreciated. So for everybody who's on the call, if you could please answer today's poll. There again, are you interested in learning more about high availability in the cloud? Definitely appreciate it. Just want to wrap this up and go on from there. All right, so give everybody 2 more seconds. All right, so I'm going to go ahead and close the poll. All right, Mike, Edwin, thank you guys so much. I definitely want to remind everyone that today's session was recorded. We'll be sending out follow-up emails with links to view the archive and download the slides. I also want to encourage you to visit mssqltips.com to access all of our free SQL Server resources. Once again, this is Jeremy Kadlec from MS SQL Tips. Thank you for attending, and definitely have a great day.